recording. So we're going to talk about Excel, the empirical rule, and the weighted mean. And that's everything that this week focuses on, pretty much.
Sounds good.
So, okay, good. And if you have any questions, like always, just jump in, okay? Just go ahead and interrupt me anytime.
Okay.
All right, I'm going to use, since I had so much trouble logging in, I'm going to use the same Excel sheet we used last week. It has 50 points on it. So let me open that up and share that. So I'm going to go ahead and let me, let's see, let me go back to the whiteboard. Cancel. Okay, share entire screen. Okay, so you should see my Excel sheet.
I see it.
Okay, so we have 50 numbers, and let's just say these are ages, and these are the same numbers we worked with last week. So I guess that'll work out really good, because then maybe it'll make more sense. And what I'm going to do first is, and you don't have to do this, but I'm going to take these numbers. So I'm going to take them and copy them. And you don't have to copy them over elsewhere, but I just like to always keep a list of the original problem. So to copy them, you just go Control C for copy, and then I'll come over here and I'll just put it over here. Now, like I said, there's not really any reason you need to do that, but I like to keep a list of original numbers. And then what I'm going to do is I'm going to take my new column and I'm going to sort it. So I'm going to go over here to sort, and I'm going to go from smallest to largest. So you should really always sort your numbers. And then you have a field, you can see exactly that 20 is our min and 50 is our max. And so the first thing I'm going to do is just find the mean. The mean is exactly what we use all the time. Sometimes when you use the word average, you're talking about three different things. You're talking about the average, like we're going to do here. The mean, the mode, the median are all averages, and they're also called measures of central tendency. So the fancy name for these things is measures of central tendency. So here we just go equal average, and we're going to take all these numbers. And I'm also going to talk about percentiles and quartiles today too. So just press that and press enter. And 35.24, go about 2-3 decimal places is our mean. So to do that, you just go equal average. So you can see that on the top right here where the function bar is, average. And that makes sense, right? 35 is right between 20 and 50. So make sure your numbers make sense. Okay, and now we're going to find the mode. The mode is the most often used number. So we can just type in mode, and we can do multi. I don't know if we have more than one. You are allowed to have more than one mode. The number that's used more often. So if we use multi, we may have more than one mode here. And then do the same thing, just press enter. And it's 37. So let's go down our list and look at 37. Now 37 was used 1, 2, 3, 4 times. So 4 times would be the most that any number is used on this list. Okay, so the number 37 was used 4 times. So that was the number that's used the most. Like 24 here is used 3 times, so that's that's not enough times. So if there were another number that was used 4 times, then we would have 2 modes. But right now, that's 37. You don't really have to do anything else with that. So modes would be used like if you own maybe a clothing store, and that would be, you would want to know the mode because that is the most that people buy, like the most size. Do you want to stock smalls, medium, or larges? The mode will tell you that, you know, which one did most people buy, the small, the medium, or the large. So that's where that would be used. Now, median is the exact middle number. So we can do that with Excel, but I'm also going to show you how to do it longhand because you're not always going to have Excel. So the median, again, you take and copy all your numbers. And here I have 50 numbers. Press enter. And again, let's just see equal median. That's the formula. And the median, the middle number, is 36.5. Now, the other way you're going to do that is you're going to average the 2 middle numbers. Now, if you have an odd number of numbers, then it's just the middle number. Okay, so if I just had these 5 numbers, you would just pick the middle number. Like if you had 5 numbers, there'd be 2 below and 2 above, and there'd be 1 middle number, and that would be your median. Well, here we have an even number of numbers. So what's half of 50 is 25. So we're going to average the number in position 25. Let's see if I can. In position number 25, hope you can see that, is 36, and position 26. So there's actually 2 middle numbers. Position 25 means that there's 24 numbers below it, and position 26 means there's 24 numbers above it. So there's 2 middle numbers here, 25 and 26 position, which you're going to average those 2 numbers, 36 and 37. Well, what's the middle of 36 and 37? It's 36.5. So, I mean, to do that, you would just say equals 36 plus 37 divided by 2 if you were going to do it longhand. And that would give you 36.5. So again, let me just write out the formula without the equal sign so you can see. So again, if you have an even number of numbers, you take the 2 middle numbers and you average them. If you have an odd number of numbers, there's just 1 middle number and you take that. So that's the median. And the median is used all the time for like house prices, median wage. We don't use average because average, there might be, or the mean, because there might be really highs and really lows, and that knocks off the actual amount, actual average. So the median is used for house prices and, like I said, wages, and it gives you a more even picture. Okay, then we would want to find the minimum. So suppose these numbers aren't in order, then all you have to do is go equal min and take all your numbers. And we know it's 20 already, but I'm just going to do it anyway. What did I do wrong here? Oh, I didn't put my, let's see, equal. I didn't put any parentheses in. There we go. So make sure you pick all your numbers, press enter, and it's 20. We knew that. The max is 50. So, I mean, you don't actually have to do this, but I'm just going to show you. So max, if you had 1,000 numbers, you know, you might want to do it this way. If you didn't put your numbers in order, and that's 50. So the range is something that you'll be asked to find. So the range is the max minus the min. That's it. The like temperature range, like the range of temperatures today was maybe 20 degrees from say 50 to 50 degrees was the high and 30 degrees was the low, so the range was 20. So it's just the max minus the min, or the high minus the low. So we could just say equals the max minus, and then we pick the low, and we have 30. But I mean, again, on this problem, you really didn't have to use Excel to find the range. Okay, the next thing that we can find is the standard deviation. Okay, standard deviation, and you'll do a little bit more reading and research on this, but just quickly, standard deviation measures the spread of your data. So if your standard deviation is high, a high number, then it's way spread out. If your standard deviation is low, then your data tends to be closer together. But you can do some more work on that. And then ask questions if you have any. So there's two types of standard deviation. There's population standard deviation, which means it's the whole population. And if you look up the formula for it, in the formula, there's a step where you divide by n. And n is the number of things in your population. Okay, so here's the difference between the two standard deviations, which one is for population and one is for sample. For the population standard deviation, so populations are bigger, you're going to divide by n, the number of people or things in your survey or whatever you're looking at. Okay, for the standard deviation example, the formula is division by n minus 1. And that's supposed to give you a closer or a better result since the sample is smaller. Okay, so you can read more about that, but the difference between the two is you would just do STDEV.x. Well, let's do population first. So it's STDEV, standard deviation, .p for population. So if they ask you to find the population standard deviation, and pretty much they'll tell you that, then you just select all these numbers and you get this number. This is standard deviation for population. Okay, if you do the sample, which would be DEV.S for example, so you would pick that formula. And again, jump in if you have any questions. Press enter, and that would be your standard deviation for example. So they're really close together, but you have to decide which one to use, and it will tell you that in the problem. And I'll talk more about standard deviation when we do the empirical rule, which I'll do next. Okay, so let's just right now find the numbers, and then I'll show you what they mean. Okay, then there's something called the variance, and that measures variability. And again, you can read more about the variance, but what it is, it's the standard deviation squared. So that caret, that upside down b means exponent. It's just, you're going to take these numbers and you're going to square them, and that gives you the variance. So in Excel, though, there's two of them, just like standard deviation. We do var.p for population. So we're going to do the population one first. And make sure you get all your numbers when you're selecting your numbers. And okay, so that's the variance for a population. And notice it's bigger, But that should be the 8.9 square. So that square just means 8.9 times 8.9. And then we're going to do the variance for the example. Now, we really don't use variance very much at all in our work. We're going to use the standard deviation, so that's what I'm going to concentrate on. But it's easy to find in Excel. If you look in the book, you'll see the formula is pretty complicated if you work it out longhand. So I'm not even going to go into that, but it would be good for you to take a look at that to see how complicated the actual formula is to get these answers. Okay, and again, I'm going to, when I do the empirical rule, we'll talk about standard deviations some more. Then they're going to ask you about percentiles. Okay, so if we want to find, say we want to find the 30th percentile. It's the number where 30% of the data lie below or at. So this textbook includes the number. Instead of just saying it's less than 30% is less than, they use less than or equal to. So our definition, and different books do different definitions, our definition includes the number. So that's why I say the 30th percentile is the number where 30% of the data lie below or equal to. So at means equal to. So if I wanted to find the 30th percentile for this, or any percentile, you would just type in equals percentile inclusive, okay, the INC. So you would use percentile dot INC. The EXC is exclusive, and that means it would just be below, not at that number. So inclusive means we can include the number when we're talking about the 30% below or equal to. So we use inclusive in our definition. And the announcement I sent out shows how to do it longhand. So I'm also going to go to the whiteboard and show you how to do it longhand. And the numbers won't add up. And that's just, let's see, too few arguments. Let me see. Oh, I have to do comma. I have to tell it which I better stop talking so much. I have to put in what percentile I want. So I want 30%. You put in the percentage or the decimal. You put in 0.30 or just 0.3. Okay, so when you're finding a percentile, we use the INC, which means inclusive, and then we pick our array. Those are the set of numbers, and then we tell it which percentile we want. And in this example, I just picked 30. So we're going to do the 30th percentile. It's 29.7. So let's take a look at our data. 29.7 is about right here. So what it's saying is 30% of the data is below 29.7 or at 29.7 or equal to 29.7. So if you use the percentile EXC, that means exclusive. It just means 30% is below 29.7 in this list. And that's about right. That's position 15, 15 or 16. Now, let me go to the whiteboard. And show you how to do this longhand. Okay, so in the announcement, and I don't have a preference on which way you do it. I just like you to know to do it, be able to do it both ways or either way. So what we do, like suppose I want 30 percentile. These numbers aren't going to match up because Excel is more.
I have a question. Now, are you just choosing 30 percentile as your number, or is that like a standard that's used, or that's what you choose?
That's a good question. That's just my number. This is just for this example.
Okay, gotcha.
So I can do another one with maybe 70 percentile. I can do that if right after this. Okay, so if I want to find the 30th percentile in my list, first I do the position that the number's in. That's why they have to be in order. So the first thing you do is order the numbers, which we've already done, and then we find the position of the 30th percentile. Okay, so we find I is equal to the percent, which is 0.30. Okay, so this is your the percent that you want, and in our case is 30. Again, that's just my number for this example. And then you multiply it by n, the number of numbers in your data, and we had 50 numbers. So when you do 0.3 times 50, you get 15. Okay, so this is 15th position in the list. It's not the number you want. It's the number in the position. If this number is an integer, that means no decimals. If this is what I was talking about in the announcement this week. If I is an integer or a whole number, which we have, then average that number in that position with the next number. Okay, so what it means is if I don't get a decimal for this answer, I got 15, I'm going to average the two numbers that are in position 15 and position 16. So this is just telling me where to start. This says, look at the number in position 15. Since it's not a decimal, I'm going to take the mean of the number in position 15 and the number in position 16. Okay, I'll talk about what happens if it's a decimal in a minute. So let's go back to Excel. And number in position 15, so go over here, position 15 is 29. So let me go over here. I'm going to take 29 and average it with the number in position 16. The number in position 16 is 30. So I'm going to average 29 and 30. Well, you know what that is without really doing the math, 29 and a half, but 29 plus 30 divided by 2. So that's 29 and a half. So again, those numbers aren't going to be exactly the same because Excel is more accurate. It uses more of interpolation than the formula, but it doesn't matter because look, if you have 29 and a half, it doesn't matter. You still have 30% of the numbers below that number or at that number. We don't have any decimals in this list. So for us, it's not going to matter that much that these two numbers aren't exactly the same. The one in Excel or the one if you do it longhand, that's not going to matter. So again, let's do a 70th percentile. Let's do, that's where 70% of the data is at or below that number. So that's going to be equals percentile inclusive, INC, take your list of numbers, and comma 0.70. Okay, so it's 70% is 0.70. So make sure that part is in a decimal. You don't put 70, you put 0.70. And we get 41.3. So we come down here and 41.3 is about in position 35. So that makes sense that 70% of your data is below that number or equal to that number. Now, if we did it longhand, okay, longhand again would be you take your position, I is position, you take your percentile, you take 70%, and then multiply it by n, which is 50, and we get 35. So again, since that's an integer, we're going to average the number in position 35 and 36. So again, I'll talk about this in a minute, what happens when it's not an integer, but for now, let's just finish this one. Okay, so for position 35 is 41 and position 36 is 42. So the average of those would be 41.5. So this would be 41 plus 42 divided by 2. And that would be 41.5. And again, you can see those aren't exactly equal, but they're close enough. You're still going to have 70% of the numbers below that 41 point something. All right, let's go back and talk about, well, what happens when that's not an integer? That means not a whole number and you have a decimal. Okay, so suppose I, when you did it, was your percent times n, the number of numbers in your data, and it equals, say, a decimal. Whole number, you'll have a whole number and then you'll have a decimal part. So you always round up. So I guess for an example, I could do the 20, say the 21st percentile. So that would be 0.21 times 50. Let's see, that should give me a decimal. Yeah, that's 10.5. So you would just take that number in position 11. So round that up to 11. So that would be the number in position 11. So again, if you get a whole number, that means no decimal, then you average the number in that position plus the next number. If it's not a whole number, then you just take that number in that position when you round it up. So you find your position. If it's a decimal, round up, and you take that number, position 11. So let's go back. Let's go back. And again, that's what I was saying in the announcement. So let's see, position 11 is 26. Okay, so let's see if that matches up. Let's see, 21st. So we'll do equal, percentile, inclusive. Again, our text does the inclusive. Others may not, comma, 0.21, and we get 26.9. But when we did the formula, that was position 11, and the number in position 11 is 26. So again, a little off, but it doesn't matter because you still have 21% of the data is below or at the number 26. So they're close enough. Excel again is more accurate because they do use interpolation. Okay, then also in here is quartiles. So that divides the data into fourths. Quarter is a fourth. So it's the same idea. So if you want the first quartile, that means 25% of the numbers are at or below that number. We could use percentile for 25%, but we can use quartile also. I'll show you how to use the percentile. Okay, so we're going to go also use the inclusive, and then we just do comma 1. So look at the directions. The 1 is the first quartile, which is the 25th percentile. Those are the same thing. But here you don't use 0.25, you just use 1 because we want Q1 is the shortcut to say that. We could call this Q1. So that means 25% of the data is at or below that number, 27.5. But you could also use equal percentile because they're the same thing, inclusive, and then just do 25% or 0.25. So take your data and do comma 0.25. And you get the same answer. You get 27.5. So again, the formula for quartile is use number 1 for the first quartile. And then for Q2 is the same as the median. They're equal. Q2 is right in the middle, but we can use the formula quartile inclusive. And I want to show you that it's equal to the median. And this time we do 2 for 50%. 50% of the data is at or below. Again, see the median in the directions, it'll say median value 50th percentile. And for us, we just put 2, 36.5. But look, way up here, we got 36.5 for our median. So that's always true. And then Q3 is 75% of the data is at or below that number. So I'll just put 75% is below or at. So we just go equal quartile inclusive. If you use Excel, it shouldn't take you too long to do all this. And then we do number 3. So third quartile is 75th percentile, and we get 43. Or again, you could use percentile inclusive, pick your numbers, and then do 0.75. So for percentiles, you have to put your percents into decimals. For quartiles, you do not. So you get the same answer, 43. Number 43, at 43, 75% of the data is below or at in your list. Okay, and then lastly, we have the IQR, and that's called the interquartile range. So again, it's a range. It's just one number, and it's really easy to find. It's just Q3 minus Q1. It's the middle. It's the middle where your numbers are. So it's between 25% and 75% of your data lies in the interquartile range. So we could just go Q3 43 minus Q1, and we get 15.5. All right, so that's everything that we need to do in Excel, and then I explain the percentiles and I explain the quartiles, but I can do a little bit more with this IQR and the standard deviation. I want to show you that. So that 15.5, if you look at this whole list of numbers, that means that's the middle part of your data. It's the difference between the 75th percentile and the 25th percentile. So it's called the interquartile range. Now, I want to talk a little bit about this because sometimes people mention outliers. So this is a good point to just quickly talk about outliers. I don't think you really don't have any questions on this, but it might be nice to analyze our data, the ABC data for the CEO, talking about outliers. So I just briefly want to mention that there's a formula. So outliers are data that is to the left of Q1 minus 1.5 times the interquartile range, or to the right of Q3 plus 1.5 times the IQR. So any data that is outside those bounds are outliers. That means, they're just points kind of hanging out there by themselves. They're really low or they're really high. So you can say that maybe a data point doesn't belong to your list of data, but there's actually a formula to decide that. So if we go back to Excel, and look at what those bounds would be, we would do this. We would say equals Q1 minus 1.5 times the IQR, which is 15.5. So that would be our lower bound for an outlier. Again, let me write down the formula. It would be Q1 minus 1.5 times the IQR. Okay, and this one would be Q3 plus 1.5 times the IQR. Oh, I messed up. So that would be Q3 plus 1.5 times the IQR. All right, so any data that is outside those two numbers would be considered outliers. Of this interval. So do we have anything? We don't have any outliers in this group because our lowest point was 20, not 4. We don't have anything close to 4, and we don't have anything bigger than a 50. So we don't have any outliers between or outside of 4.25 and 66.25. So there's actually formulas to decide if a number is an outlier or not. And it's not a hard formula. So it's kind of easy to tell. So that's kind of a neat thing. And again, I don't think you have any questions on that, but it might be nice to bring it in when we're discussing the our ABC problem and the discussions. I just thought it'd be a little interesting to talk about. Okay, so there's a lot for me to talk about here in this week. Let's go to standard deviation and talk about that. Okay, we're going to talk about distributions in the coming weeks. And our normal, I don't know what happened here. A normal distribution, sorry, it's kind of hard to write on the screen. Okay, we're going to first go to a, well, let's talk about what it is. It's a bell-shaped curve. And again, you can do a little bit more reading on this and a little bit more research, okay? I'm just going to quickly talk about it because it's not hard to. And the mean is always in the middle. So you have the mean in the middle. It's symmetric. That means it's equal on both sides. You have the same shape on the left and the same shape on the right. So it's symmetric. And what kind of things follow a bell-shaped curve? Well, let's talk about height. You know, most of us are in the middle. There's only a few really, really tall people on the right side. And on the left side, there's only a few really, really short people. So most of us fall in the middle. So like things like height, IQ, foot length, anything like that will follow a normal distribution. All right, let's talk about data, because we're going to talk more about this bell-shaped curve in the future. So we're not really going to spend too much time on it. But if we have this bell-shaped curve, the standard deviation tells us how spread out the data is. So if the standard deviation is large, is big, then our curve is more flat. If our standard deviation is small, then our curve is bunched together. Our data is really, really close together. And again, the mean is in the middle in all instances. So one thing that the standard deviation does is it measures the spread of the data. It's also, the standard deviation is always positive. It does other things too. Like I said, there's more to it than this, but I want you to read about it. It's not really hard to read about. We have something called the empirical rule. Okay, this just makes it easy for us to tell where our data lies. So, if we have a normal curve, we can say, okay, with the mean right here, we can say that approximately 68% of the data lies between -1 and +1 standard deviations from the mean. Okay, now when I said the standard deviation is always positive, I mean when you actually find that number, like we found it was 8.9 in our problem, when you actually find that number, it's positive. But when you add a sign to it, that just tells you that it's left of the mean. So a -1 means the standard deviation is 1, but it's to the left. So the sign just tells you the direction. Okay, so the standard deviation would be like right here and then right here. 68% of the data is right here, lies right here. So that's like the not the tall people, the normal size people or average size people, not normal, average size people are between +1 and -1 standard deviations from the mean. And again, this is just approximately, and we can just look at this graph and say that. So it makes it really nice. This rule is also called the 68, 95, 99.7 rule. Now the text uses more decimal points, but we don't have to. I think they say like 95.44%, but we're just going to use 68, 95, 99.7. Then we can also say, it also says that %95 of the data lies between -2 and +2 standard deviations. So it says approximately, this is still the empirical rule, approximately 95% of the data lies between, I don't know. Okay, lies between -2 and +2 standard deviations from the mean. So the mean, of course, is in the middle. So that's the 95%. And then it tells us, I wish this paper was a little bit bigger, but then it also tells us that between minus 3, which is about here. Usually the tail does not go beyond minus 3 and plus 3. 100% of the data is under this curve. So the whole curve represents 100%. So we usually don't go beyond minus 3 and plus 3 standard deviations from the mean, but the empirical rule says 99.7%. Approximately, the empirical rule says 99.7%. Approximately 99.7, so almost all the data is between minus 3 and plus 3 standard deviations from the mean. Okay, so again, 68% is between plus and minus 1 standard deviation from the mean. 95% is between plus or minus 2 standard deviations, and 99.7% is between plus or minus 3 standard deviations. So if you see it like in the Connect exercises, if they say 95.44, don't let that bother you. We're just going to say 95 because most texts use just 95%. So what does that mean? Let's look at a real problem. Okay, I'm just going to take a simple example. So my example is suppose we have refrigerators. The mean selling price is, let's just say, $900, with standard deviation is, say, $25. Okay, so using, and let's say they're normally distributed. So we went to, say we did 1,000 stores, and we went and got all this information, and we need to know that it's bell-shaped. So what that tells us is that, let me just try to fit that in here. We're going to draw a bell-shaped curve. The mean is 900, and within minus 1 standard deviations and plus 1 standard deviations, 68% of our store of the prices should be. So approximately 68% of the prices or the costs should be between those numbers. Now, what are those numbers? All you have to do is do this. Just do 900 minus 1 standard deviation. Okay, they're going to tell us what the standard deviation is, 25. So we're going to subtract 25, and we're going to add 25. Because it's on either side. It's 1 standard deviation on either side. So it's real simple. All we have to do is say that it's between 875 and 925. 68% of our store prices should be in that interval.
So on here, whatever you do to one side, you do to the other side, just in the opposite. If you subtract on one, you add it on the other.
Yes, because we're going to do even numbers. It's
okay.
Symmetric.
Okay.
It's always symmetric.
Okay.
And the key is the 68, 95, 99.7 rule. That's what we're using. So based on that rule, if you just add 1 standard deviation, which is 25, and subtract 1 standard deviation, which is 25, we should know that 68% of the stores should be in that region, or those prices should be in that region if it follows a bell-shaped curve. And that's all they're going to ask you to do, something like that. So where would 95% of the prices be? Okay, and again, remember, it's approximate. Well, those are within -2 and +2. And again, 900 is right in the middle. So all you're going to do is subtract 2 25s and add 2 25s. So we already subtracted 1. So we're going to do another one. And then you're going to add 2 of them. So that's saying between, that's saying 95%, approximately 95% of the prices, approximate 95% of percent, approximately 95% of the prices, approximate 95% of the stores sell the refrigerators between $8.50 and $9.50. So all you're doing is adding standard deviations and subtracting them from either side. So they're in here. So almost all of them are within -2 and +2 standard deviations. And then again, using the empirical rule, again, that's what we're talking about, it's just the empirical rule. 99.7% is between -3 and +3. So we're just going to add 3 25s and subtract 3 25s. Okay, so to get over here, we subtract 1 standard deviation, which was 25. We got to 875. And we add 1 standard deviation. Remember, standard deviation was 25. We got to 925. So that was saying 68%. And then for -2 and +2, we did another 25. So we were at 850, and we added another 25. And so at -3, we're going to subtract 25. So we're going to be at 825. And at +3, we're going to add 25. So we're at 975. So here's another way to think about it. 900 minus 3 times 25. So that's -75 is 825. And then 900 plus 3 times the standard deviation, whatever it is, they're going to tell you that is 975. So approximately 99.7% of the prices are between 825 and 875. And basically that's all there is to the empirical rule. So again, let's do it this way. All right, suppose the mean, just make up a really easy one. Mean is say it's 200 and the standard deviation is 3. Then all you do, because again, that's what the empirical rule is for, just a really easy snapshot of where the data is in your problem. So as long as it's normal, as long as it follows a bell-shaped curve, we put the mean in the middle and minus 1 standard deviation, we would just add 3. So we would get it 203. I'm sorry, plus 1 standard deviation you add, plus 2 standard deviations. So we're going to add 2 3s. So we're going to add another 3, make it 206. And so you're just moving over by 1 standard deviation each time. So the standard deviation is 3. So I'm going to add another 3. And 3 is the highest you go because that's almost 100% of your data. This way you just subtract 3. So I'll get it 197. Subtract 2 3s from 200, or just 1 3 from 197. Either way, you get 194. And then minus 3, just subtract another 3, we'll get 191. So it's saying 68% of the data is between minus 1 and plus 1. 8% of the data is between minus 1 and plus 1. 95% is between minus 2 and plus 2. And then 99.7 is between minus 3 and plus 3, approximately. So that's the nice thing about the empirical rule. Now, of course, you're going to say, well, how about if we want 50% of the data? Well, there's tables that you can use, and later on when we do probability, we're going to use this a calculator that does the normal curve for us. So right now we're just learning a quick and easy way to see where our data is. Later on we'll get more exact and we'll tables, but for our class I like using there's special calculators that I'll show you that are a lot easier. So we're gonna again, we're just doing a simple, easy snapshot. The empirical rule is 68, 95, 99.7, and it gives you an idea of what standard deviation is, so you can kind of see a picture of it. Okay, and I have one more. I know I'm going over, but I want to do this one. In the Connect exercises, you have a problem that is called a weighted mean. So I want to show you quickly. Before I do that, you heard of grading on a curve?
Yes.
I don't think people would really want you to grade on a curve. I don't think students really would. I wouldn't want to be graded on a curve. Let me put it that way. The reason is because that means, okay, 68% would be getting a C between minus 1 and plus 1 standard deviations if you use this normal curve. So grading on a curve means grading on a normal curve, which would be almost, well, so yeah, 68% would be getting C's. Okay, there's this little portion between minus 1 and plus 1 and plus 2 standard deviations. That would be the B's, and that's only a 13.5%. And this would be the A's after the 2, which would only be 2.5%. So that's not very much. And if you go this way, minus 2 standard deviations, that's the D's, would be 13.5% of the class. And then the F's would be 2.5%. So that's from the empirical rule. 68% of the scores are between minus 1 and plus 1 standard deviations. That's what it would look like grading on a curve, which is really not fair. Most of the people are getting C's, and that probably doesn't reflect what people have learned. So just wanted to quickly talk about that. Okay, the last thing is a weighted mean. So this is if you have like a chart. Say this is the price of 3 cars. This is my example. So I have a Model A, Model B, Model C car. I are selling these cars. So this is the amount sold. I sold 8 A's, 10 B's, and 12 C's. Again, I'm just doing a quick example. And the price, let's say these are used cars, is $10,000 for A, $12,000 for B, and $8,000 for C. So they want you to find the mean of the price, the mean price. And what you could do is just count all 8. So in A you would have sold 80,000. You could list them all out, but it's easier just to use the formula. So you have 8 A's, and they're worth 10,000, or they sell for 10,000. And then you had 10. So those are your weights, are your numbers. That's why it's called weighted. And then you had 12, 8,000. And on the bottom would be the total sold, not the price, but the total amount sold, and that adds up to 30. So you would do weighted mean that way. So I'm trying to figure this out. Let's see. Okay, so that would be the weighted mean. Now in your these would be considered the weights. 8 of 10,000, 10 at 12,000, and 12 at 8,000. So this is the amount is your weights. So in your exercises, those are the credits. Like it's an A, B, or C scenario. Like you get
excuse me.
Like an A is worth 4 points, and a B is worth 3 points, and a C is worth 2 points. And that's how they do it there. So you would just use those credits, and the C is worth 2 points, and that's how they do it there. So you would just use those credits as your weights. So these would be your credits, and those would be your weights, and you would work it the same way. So an A is like 4 points, and say you got 3 A's. A B is worth 3 points, and you got 2 B's. And a C is worth 2 credits, and you got, say, 1 C. So you would work it out that way. All right. But that's all I have for examples. And I pretty much focused on everything that you needed to work on. But if you have questions, you know how to contact me.
Yes. Okay.
All right.
I think I'm good. It's always just good to sit in. Thank you so much. I appreciate it.
Okay, well, thank you. And like I said, if something comes up, I can get on this again, and we can work through it on Collaborate or however you want to do it.
Okay. Thanks again.
All right. I'll post it right after this. Good night.
Okay, great. Good night.